Welcome everyone to the live interactive session number 8 of the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today we are going to discuss some sample problems which are related to assignment number 8. I am the TA for this course and my name is Ananya Mandal. So the first question is, in the ABBT matrix of the anti-symmetric laminate plus 45 minus 45 plus 45 minus 45. So which of these options are correct? Options are A16, A26 equal to 0 and D16, D26 equal to 0. Or option B, only A16 and D16 is equal to 0. Option C, all the elements of B are 0. Or option D, all the elements of D are 0. So the first thing you will see in the question is saying it's an anti-symmetric laminate. So for symmetric laminate, the B matrix will be 0. So here it is anti-symmetric, so B matrix will not be 0. So in the last session, we discussed some points that will be useful to answer this question. So the two most important points for answering these questions are this point number 3. This says that if for every lamina of plus theta orientation there is an identical equal in thickness and material lamina of minus theta orientation. Okay. So first point they talk about a balanced laminate. So balanced laminate we talked about last class that if for every lamina of plus theta orientation there is an identical equal in thickness and material lamina of minus theta orientation. The normal stress shear strain coupling represented by A16 and A26 in the A matrix for the laminate is equal to 0. The location of these two laminas are arbitrary. Such a laminate is called a balanced laminate. Am I not
Your
audible?
voice is coming. I don't know. Yeah, yeah, audible, ma'am. You are audible.
Okay. Hare Krishna, can you check the audio from your side?
Yes, ma'am. They should check audio from his side. Your voice is coming now. No problem.
Okay. And I will continue. Okay, so this is a balanced laminate. So what happens in a balanced laminate is there will be a positive and there will be a negative for the similar angle. So as you can see in the question, the laminate is made of plus 45 minus 45 plus 45 minus 45. So for every plus 45, there is a minus 45. So that creates a balanced laminate and it doesn't depend on where is the position of it. It just says that if there is a positive of any angle, there should be a negative of that angle, then it will form a balanced laminate. And for a balanced laminate, the normal stress shear strain coupling will be 0. That is A16 and A26 of the A matrix will be equal to 0. So that option A, you can see that option is given A16, A26 equal to 0. So that will satisfy. Next thing is The next point, that if for every lamina of plus theta orientation above the midplane, there is an identical lamina in thickness and material of minus theta orientation at the same distance below the midplane, then the bending moment twisting curvature coupling represented by D16 and D26 in the D matrix for the laminate is 0. So here, if we have to take the midplane, so it will be plus 45 minus 45, then comes the midplane and plus 45 minus 45. So midplane will be here. So from the midplane, wherever there is a position for plus 45, at the same position there should be negative of that theta, so minus 45. Similarly here it is minus 45. At the same position there is plus 45. So in this case, the
Ma'am, you did not record your video because this also you put in on website, no?
no, I am recording. Yes, it is recording.
Here not showing recording your video like that.
No,
This is recorded, then showing.
from Gmail I don't record. I record it with
Oh,
some different software.
okay, okay.
So from this point also we get that the bending moment twisting curvature coupling will also be 0. So D16 and D26 for this laminate system will also be 0. So option A is the correct one. Next question is, which of the following is a quasi isotropic laminate? So a quasi-isotropic laminate results when the individual lamina are oriented in such a manner as to produce an isotropic A matrix. This means that the extension and shear are uncoupled. That means A16 and A26 is equal to 0. And the components of A are independent of laminate orientation for a quasi-isotropic laminate. And another way of finding out whether it is a quasi-isotropic laminate is, if there are n laminates, then the orientation of the adjacent layers will be pi by n. And this n has to be more than 3, more than equal to 3. So here, in all the options, number of layers are 4. So if you divide pi by 4, it gives 45. So uh, any of these sequences where the orientation of the adjacent layers is different from each other with the angle of 45, that will be the correct answer. So option B here will be the one which has a 45-degree uh, difference in the adjacent layer, that is 0 and plus 45, and also minus 45 and 90. Then you will think that plus 45 and minus 45, between them it's 180. It's not 45 degree. So here at the mid, if we take a midplane, these 2 points will again, this point, the third point, it will form the balanced laminate. So for a balanced laminate, already there is A16, A26 equal to 0. So this plus 45 minus 45 will be the case of balanced laminate. And then from minus 45 there is a 45-degree change to 90-degree, and from 0 it is a 45-degree change to plus 45. So that causes isotropic laminate, and the A matrix will be isotropic. And this whole condition is known as a quasi-isotropic laminate. The next question is, in the ABBD matrix of a quasi-isotropic laminate, which of the following is true? So a quasi-isotropic laminate results when the individual lamina are oriented in such a manner as to produce an isotropic A matrix. And as discussed before, that A16, A26 values will be equal to 0. So the option A and option B, we can see A16 and A26 is equal to 0, and also option D. Now the A matrix for a quasi-isotropic laminate looks like this, where they have A11 and A22, and A11 will be equal to the position of A22, it will be same, and the A66 value will be equal to A11 minus A12 by 2. So this is the way quasi-isotropic laminate will have an A matrix. So from that we can see option A, that A11 and A2 will be equal. This A11 and this A22 will be same. A16, A26 will be equal to 0. and the A66 value will be equal to A11 minus A12 divided by 2. So that forms a quasi-isotropic laminate. Next question is, for a symmetric laminate, the effective extensional Young's moduli are Ex equal to 30 gigapascal and Ey equal to 10 gigapascal. So if the effective in-plane Poisson's ratio for the laminate is mu xy equal to 0.3, then the value of effective in-plane Poisson ratio mu yx is. So uh, in very previous sessions, also in the beginning sessions, we got a relation between Young's modulus and Poisson ratio. So that same expression will be used here. Here it will be mu xy by mu yx equal to ex by ey. There it was in terms of 1 and 2. Here it is in global axis. Otherwise the equation is same. So from this equation we can get the Poisson ratio as mu in plane Poisson's ratio mu yx, which will be equal to mu xy ey divided by ex, and you will get the value. The next comes that a 0 plus 45 minus 45 90 symmetric laminate is subjected to only nx and ny, and the stresses at the mid of top 0-degree ply was found to be sigma x equal to 20 megapascal, sigma y equal to 5 megapascal, and tau xy equal to 0. If the same nx and ny are applied to another laminate made from same lamina, but the stocking sequence 0 plus 45 minus 45 90 2s, that is, it is twice symmetric, so that the number of lamina is doubled, the stresses at the mid of top 0-degree ply will be. So here what is given to us? First it is given one laminate structure, that is 0 plus 45 minus 45 90, then symmetric, that means there will be 90 minus 45 plus 45 0. So this laminate we have with 8 laminas. It is subjected to loads, that is nx and ny, and we have to find what will be the uh, we have to find the strain of the 0-degree ply. Sorry, we have to find the what will be the stresses at the 0-degree ply, which is at the top. And for this sequence, the stresses are already given, that is sigma x, sigma y, and tau xy value is given. And in the second case, they are doubling the amount of laminas, and we have to find what will be the stress. So it is, we have to consider these two cases, and then we have to find a relation between it, such that we can find, we know the stresses of one condition, we have to find the stresses of the next condition with double the laminas. Now for that, first we need the relation between stress and load, and stress is related to the strain. So with the equation of load is this: nx ny nxy is equal to the A matrix multiplied by the midpoint strains epsilon x, epsilon y, and gamma xy. So from this equation, the equation for the mid-plane strains will be equal to the inverse of the A matrix multiplied by the loads. Okay, so this is the relation we are getting with respect to strain and the inverse of A matrix and the load. Now this A matrix, we know how to find the A matrix. For that we will need the stiffness matrix, reduced stiffness matrix, and the thickness of all the laminas. Now when in first case there are 8 laminas, so the value will be there will be some value of the A matrix, and when we double it, so the value of this A matrix will also double, because A matrix is just the summation of the thickness and the reduced Q matrix of each lamina. So if the laminas are doubling, so the A matrix values will also double. So for the particular stocking sequence, if we increase the number of lamina by 2 times, then the A matrix values increase by 2 times. And only Nx and Ny are applied, so only mid-plane strains and no curvature will be there. So we will only use the relation between the load and the mid-plane strains. So the stresses will get reduced by 2 times for the same applied Nx and Ny. So as A value is increasing, so the stresses will reduce by 2 times. So we have to, as you can see here, A value will increase by 2 times. When it will put in this way, it will be half. That means the strain values will be half. And if strain values are half, then the stress values will also be half. So according to that, we will get what will be the values of the stresses for this new sequence, which will be half of the previous one. So previously sigma x was 20 megapascal, it will half, will be 10 megapascal. Sigma y 5 megapascal will become 2.5 megapascal. So it all, the stresses will depend on the strain, and the strain value we can get from the load with and the A matrix. And only thing that is changing is the value of A matrix, that is doubling. So we have to correlate the doubling, or suppose you get a question where there are three of it, so it will be three times. So you have to get a relation between the what is the increase in the value of the A matrix, and if load is same, then what will be its relation with the strain and the stresses. From that you can directly find the values, which of these values will be the correct one. The next question is that the reduced stiffness matrix for unidirectional graphite epoxy lamina is given. So the Q matrix is given. Then if a 090 symmetric laminate made from unidirectional graphite epoxy lamina with lamina thickness of 0.1 mm is subjected to an in-plane load of Nx 100 Newton per meter, the global axis strains induced in each ply will be. So here we have, first thing they have given us the reduced stiffness matrix for a unidirectional graphite epoxy lamina. So suppose we consider this reduced stiffness matrix for 0 degree. So it's for 0 degree lamina, we are considering this matrix, the reduced stiffness matrix. And in that laminate, we have the angles 0 and 90 in symmetric. So it is 0, 90, 90, 0. So for the 90 degree, so there is equations that are used with respect to the angle, how we can change for different angles the reduced stiffness matrix. So you can use those equations, or the simplest way to convert 0 degree to 90 degree is that the Q11 and Q22 values interchange. So for if for 0 degree, this is the reduced stiffness matrix. So for 90 degree, here in place of 200, it will be 10, and in place of 10, it will be 200. But this condition is only for converting 0 to 90. For different angles, we have to use the equations which are required for changing all the components of this reduced stiffness matrix. Okay, so now we have the reduced stiffness matrix for both 0 and 90 degree. Now we have to find the A matrix, because we are given the load, the in-plane load Nx value is given, and we have to find the strain. As they are not talking about any curvature, so we assume that the K value will be, there is no curvature, so the K value will be 0. So the load will be directly proportional, load will be equal to the A matrix and the mid-plane strains. Okay, so from that equation that you can see here, the loads is equal to A matrix and the mid-plane strains. And the first thing is we have to find this A matrix. To get this A matrix, the equation is we have to sum of the reduced stiffness matrix multiplied by the thickness. Now all the laminas have the same thickness, that is 0.1 mm. So here you can see how to solve the A matrix. So first we are multiplying by 2, because there are two 0 degrees and two 90 degrees. So 2 multiplied by the matrix for 0 degree. Now 0 degree multiplied by its thickness, as zk minus zk1, k minus 1 is as the thickness, so multiplied by thickness, and then the unit, we have to take care of the unit. As it is gigapascal, so there it is 10 to the power 9, and this thickness is in millimeter, so it will be multiplied by 10 to the power minus 3. Okay, so we are getting the A matrix. How? Two times of two 0 degree laminas. So 2 multiplied by the stiffness, reduced stiffness matrix of 0 degree, multiplied by the thickness of that and that laminas into, we have to take care of the units because the reduced stiffness matrix is in gigapascal and the thickness will be in millimeter. So millimeter it will be converted into 10 to the power minus 3 and gigapascal in 10 to the power 9. Similarly, we add and multiply by 2 for the 90-degree lamina. So 2 into the 90-degree lamina's reduced stiffness matrix, which I explained that we just have to interchange the Q11 and Q22 values from 0 to 90 and then multiply it by the thickness again. So this calculation will give you the whole A matrix. Since this is a symmetric one, so B matrix will be equal to 0 and from this equation we can get the mid-plane strain. We will inverse the A matrix and multiply it with the loads. Load only Nx value is given equal to 100 Newton per minute. Ny and Nxy values are equal to 0. And from that equation, this equation we will get the value of the mid-plane strains. So mid-plane strains you can see equal to A inverse multiplied by the load Nx equal to 100. From that we will get the mid-plane strains. Now this lamina is subjected to only in-plane load Nx and no moments. So there is no curvatures. So here the global mid-plane strains will be equal to the global strains. So we have to find the global axis strains and first we found the value of the mid-plane strain. And now there is an equation relating mid-plane strain to the global strain, that is mid-plane strain equal to global strain plus the thickness into the curvature. Now curvature value is not there. So directly mid-plane strain will be equal to the global axis strains. From that we will get the values of epsilon x, epsilon y and gamma xy. So we have to do all this calculation and finally we can get the answer. So this steps looks easy to explain, but it will take a lot of calculation and also there are very much chances for not proper unit conversion and mistakes. So you have to take care of that and calculate it properly. Next question is that the reduced stiffness matrix for unidirectional graphite epoxy lamina is given, which is same as the previous one. And the coefficients of thermal expansion of unidirectional graphite epoxy lamina are alpha 1 equal to 1 into 10 to the power minus 6 meter per degree Celsius and alpha 2 equal to 20 into 10 to the power minus 6 meter per degree Celsius. If a 090 symmetric laminate made from unidirectional graphite epoxy lamina with lamina thickness of 0.1 mm is subjected to only a thermal gradient delta equal to 50 degree. The global axis residual thermal strains in 0 degree lamina are. So here the same laminate used like the previous question, which has 0, 90, 90, 0 of 4 laminas. It is given the Q matrix, the reduced stiffness matrix. We consider it for 0 and for 90 we know we have to change the Q11 to Q22. Then we are given the coefficients of thermal expansion of the lamina. That is alpha 1 and alpha 2 is given to us. And also the thickness of each lamina and the change in temperature. So the load here is caused because of the change in temperature. So it is the thermal load. So load because of this temperature, because of thermal gradient. So first thing first, we will get the A matrix. Like we did in the previous question, we will find the A matrix like this in the same way. Then is the thermal coefficient transformation. Transformation because we have to find our final value in terms of global axis. But here for each lamina it is given in the alpha value is given in the material axis. So for each laminas we have to convert this material axis to global axis. So from that we can get the free thermal strain of each ply. So free thermal strain of each ply is given as epsilon x, epsilon y and gamma xy equal to del T into alpha x, alpha y, alpha xy. This is of each ply. So this alpha xy and alpha xy values will be different for different laminas. So from that we will get the free thermal strain of each ply. Now that's why, to make this question easier, they only said we have to find the values for the 0 degree lamina, which is the top one. So for the 0 degree lamina, the free thermal strain will be equal to the delta T, which is 50 degree, into the alpha x, alpha y and alpha xy value of the 0 degree angle lamina. So that is, this one we will consider will be same, alpha 1, alpha 2 will be same for that of 0 degree. So we take alpha 1 equal to 1 into 10 to the power minus 6, alpha y equal to 20 into 10 to the power minus 6. So from that we will get the free thermal strains of the 0 degree lamina. We got that. Now we have to find the global strain of the whole laminate. To find for the global strain for the whole laminate, we will again need the same equation, which will consider the load and the A matrix. So here the global strain for the laminate will be equal to the inverse of A matrix and the load. But here, as I said, the load is not direct load. The load is because of the change in the temperature. So there is an equation for the load due to thermal gradient. So that equation is like this. So you can get the values of this load equal to del T into summation of uh, uh, the stiffness reduced stiffness matrix multiplied by the thermal uh, gradient, multiplied by the coefficient of thermal expansion into the thickness. So this equation already sir has taught will be used to find out what will be the load because of any temperature change. So once we get this load value, the A inverse value we can get after getting the A matrix. So then we will multiply these two and we can get the global strain of the laminate as a whole. So it's the same concept as before, but only thing different here is the load because of temperature difference. And to find that load, we have to use this equation. So after finding the global strain for the whole laminate, we have, as they have asked in the question, what is the residual thermal strain in the 0 degree lamina? So to find the residual thermal strain, we have to subtract the free thermal strain of that single ply minus the global strain of the whole laminate. So, therefore, the residual strain will be equal to the global strain of the laminate minus the free thermal strain of the 0 degree lamina, which they have asked in the question. And from that, we will get the final residual thermal strains. So, this is a very lengthy question, and there are many steps and also many chances of getting wrong answers. So be careful while solving this one. Yes, any doubts? Yes, Afjal, do you have any doubts?
Yes, ma'am, but I didn't understand fully last question, ma'am. How you can calculate a matrix?
Calculate A matrix.
Yes,
Uh,
yes,
okay,
ma'am.
I will explain it again. It's the same thing, like question number 6 and 7, in both of them calculated the A matrix similarly. So for A matrix, this is the equation. Okay, for A matrix, B matrix and D matrix, these equations are given, how to solve. So this equation signifies that first, suppose you have four laminas. Okay, suppose you have four laminas, the 0, 90, 90, 0. So you have to, as you understand this symbol, it is the summation. So you have to add the Q multiplied by the thickness of each laminas. So the first lamina, suppose first lamina here is 0. For 0 degree, what will be the Q, the reduced stiffness matrix? So this is the reduced stiffness matrix for the 0 degree. So multiply the reduced stiffness matrix of 0 degree into the thickness. The thickness for each lamina is given as 0.1 mm. So first you did this Q matrix multiplied by the thickness zero point
Ma'am,
0.1.
ma'am, but last question, there is no given na, for the thickness. How in last this
Thickness is
question
given
seven
as
point.
0.1.
Where is ma'am? Ah, yes.
Okay, so this question and
Mm.
this question have same data. Only the nx value is different. So this is, if you understood how to get the A matrix here, the same thing happening here also.
Ma'am, why we are taking 2 here?
What?
Why we are considering
Why
2
multiply
into
two here, ma'am? In matrix. Why we multiplied two into something like that?
2 because see the matrix laminate they are saying is 090 symmetric. So whenever there is a S under this bracket means there are double of it. So there will be 0, then 90, again 90 and 0. So there are 4 laminas, right? So for 4 laminas, 2 of them are 0 degree, 2 of them are 90 degree. So I combined the two 90 degrees together by multiplying it with 2. Again for the two zero
okay,
degrees, multiply it by 2 to combine it.
okay,
Okay,
fine.
ma'am. Mm.
Any other doubts? Did anyone try to solve the questions of assignment 8? Did you have problem in that for this whole calculations?
It was very big, ma'am, taking very lot of time for it.
What?
It seems very big, ma'am, taking a lot of time.
Yeah, these two last two questions, because when the concept of ABD matrix comes, the equations and everything becomes lengthier. All the matrix you have to multiply and solve. And also take care of the units because you have to convert your millimeter to meter and gigapascal to normal pascal and then only solve. So first convert them into the basic units and then solve. So a lot of mistakes happen in the units here.
Okay, ma'am, okay.
Ma'am,
Yes.
ma'am, solution of these questions are quite lengthy, so there will be less chances to come in the examination.
About examination, I have no idea what type of questions sir will give. So, but sir will give according to the time constraint only.
Ma'am, is this paper in MCQ mode or pen paper mode?
That also I don't know. You can ask in the discussion. Sir might be able to answer what he will. If he wants to tell, then he might be able to answer what type of question will come. So it's better these questions you ask in the discussion where sir can see it directly.
Okay, ma'am.
Shall I pose 2 questions here? Can you please clear to us?
What?
Okay. Can I pose 2 questions, assignments question doubts here? Can you clear me?
Okay, put it in like the chat section.
From it is in a symmetric limit. We know it is 090, uh, again 90 0. Then
Yeah.
then A16 and A26 both 0 and D16 and D26 both 0. We are right, ma'am?
In the last class, I have discussed about cross-ply symmetric laminate, right?
Yes, yes, ma'am. Yes, ma'am.
मैम इसमें तो मैम ये होना चाहिए ना A16 A26 equal to 0, D16 D26 is equal to 0 and all the elements of B matrix are 0.
Yeah. See, last class I had explained the same. I took the same question, I think.
Yes ma'am.
This one. All of these will be zero. Like B matrix will also be zero, A16,
Okay.
A26, B16.
11's B also 0 here, ma'am.
Yeah, B will be zero. Anything symmetric, first thing is you eliminate the B matrix. It will be zero.
Okay. But in balanced symmetric matrix, B is not 0. Am I right, ma'am? B and D's are not 0. Only.
Yeah, A16 and A26 will be zero for balanced one. Um, so huh, this statement is for the balanced one. That if for balanced, yes, if there is symmetric, B will be zero. If it is not symmetric, B won't be zero. Only A16, A26 will be equal to zero. And D16 and D26 can be zero. That you have to check again what is the position of the plus and minus. So if at the same position there is plus and below the midplane there is minus of that angle, then it will D16 and D26 will also be zero. So it balanced one can also have this D16 D26 equal to 0 depending on where is the position of those angled laminas. Because balanced one they only talk about there should be a plus and minus. They are not talking about the position. So if you see the positions are like correct according to this point number 4, then again D16 D26 will be 0. So you have to just you see balance doesn't mean that the D values and B values won't be equal to 0. So you have to check the position of your laminas.
Yes, here the position is balanced, ma'am. Positive, again negative, again positive, ma'am.
Yes, for every positive there is a negative. So 45 negative,
Yes,
positive
ma'am.
40, 30. Yeah, so this will be
So
balanced.
A16, A26 will be 0, D16, D26 will be 0.
No, D16, D26 will not be equal to 0. B matrix will be equal to 0 because it is symmetric. But D16 and D26 will not be equal to 0. Because see, if you do the midpoint here between minus 45, minus 45, so from midplane, where there is a minus 45, there is minus 45. But if D16, D26 is equal to 0, then there should be a positive 45. Similarly, for minus 30, in the opposite side, there should be a plus 30, but here it is minus 30. So in this question which you showed, the A16, A26 will be equal to 0 and B matrix will be equal to 0.
Ma'am, but in answer they have shown both option A16 will be 0, then B matrix also 0 like that.
So consider the option A, but B matrix should also be 0 because it is symmetric one. Let me see.
Yes ma'am, there are
But it is
multiple
a
choice.
balanced symmetric one, ma'am. It is a balanced symmetric, no, ma'am. It is a balanced symmetric.
Can you
So
choose more than one here?
no, no,
Ma'am, it
ma'am.
is a
Only one
multiple
can choose.
choice.
So only one of them is correct, right?
No,
No,
ma'am,
no,
there
we
is more
can
choice
choose.
to choose.
Okay, if it is more than
You
one
can
choice, then
choose
it is easy. A is correct and C is also
A
correct.
and C.
Yeah,
Okay.
because it is
Yes,
balanced
No,
ma'am.
no,
as
ma'am.
well as symmetric.
Only one choice is correct, ma'am. In the assignment, ma'am.
No, no.
No, no, I
No, we
see
can
that
select both.
uh, when I select both, then only selected one like that.
There is more options to choose.
I don't know. But when I mean, we choose, o- we already choose one. Then we go to the another. Choose to another. Then the previous one is removed.
If there will be a
So only
square sign, then you can choose more than one.
Yes, yes, you are right.
yes,
If it is round term like that, we can choose only one. But in terms of square options, we can select
yes,
both.
yes,
Correct.
Yes.
Exactly.
yes, yes.
Okay, so that one is solved. What is the next one? Carbon epoxy laminate having stacking sequence as 0, 45, 30, 30, 45, 0. Laminate. So it is symmetric. D will be 0. D matrix will not be 0 because all the elements of D as 0 will be incorrect because for D16, D26 to be 0, there should be a plus and there should be a minus at the opposite direction. So I think it should go with
Ma'am,
option
your
C
your
only.
screen is ma'am, your screen is not
Ma'am,
shown.
but here B16 and B26 also zero only, ma'am. Here also both are zero.
B16,
Because
B26
in
are 0,
stacking sequence,
but it says only
no, no,
B16,
but
B26.
correct. Only, yeah, 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 correct.
Yeah,
Then
but the
all the
whole
other
matrix will be 0.
C will be the exact answer. Yeah.
Yeah, C will be the
Ma'am,
answer.
option C is correct.
Yes. Because A is saying only is not correct. That's why C option will be the correct one. Symmetric B matrix whole matrix will be 0.
If it is symmetric means then the B also zero, then A matrix, D matrix both will be zero. Am I right, man?
Which one?
No, it is general question for a symmetric matrix. The B terms are zero. Then A and D, both A16, A26, then D16, D26 both will be zero. Am I right, man?
For symmetric?
Yes.
No, no, no. You can't say that. Because see, A16, A26 concept
Ma'am,
comes for
can
mostly balanced one, right? Balanced symmetry always has a plus and minus. This question, this one you can see, the laminate sequence is all positive. There is no negative. So if there is no negative for every angle, it won't balance. If it won't balance, the A16, A26 values will not be equal to 0. You need a positive and negative for the same angle, then only it will be balanced and A16, A26 will be 0. You do one thing. In the last PPT, I wrote all the definition, all the points for which
yeah,
A16,
ma'am,
A26,
I have
B16.
taken, I have
Yeah,
seen, ma'am. I have downloaded the slide. I have a screen a picture we have posted there.
yeah. So that will clear up your doubts, like which conditions it will be considered balanced and which symmetric and all. So always go with that one. So balanced always will have both positive, negative. Then it will be balanced. Then A1 to A26 will be equal to 0. And for D1 to D26 equal to 0, at the midpoint, above and below, there should be a positive and similarly a negative. So these three things you have to see. Symmetry, whether there is a positive and negative for all the angles. And third is in the midpoint, what is the position of positive and negative.
Okay, ma'am. Okay.
Anything else? Any other doubts?
Ma'am, in problem number 2, uh, in assignment they are asking Young's modulus, ma'am. They have given a longitudinal modulus and Young's modulus.
I didn't understand. Can you write it here in the messages?
Yeah. In effective plane, longitudinal head modulus have been given. It was balanced symmetric matrix. Then they are
Hmm.
asking longitudinal Young's modulus.
Young's modulus. So, the question I just discussed, uh, this
Discussed about
question,
the
huh?
volume ratio. Yeah, yes, ma'am.
What? Huh, this question. So, as you can see here, they're relating the A matrix with the stress and modulus. What is modulus? It is stress by strain. So, from this relation, as you can see, what is happening? The A matrix will decrease in the question that you have shown, right? Initially, there are there are 4 to 4, 8, 16. Initially, there was 16 laminas. Then it got reduced to 8 laminas because from 2S it became S. So the A matrix will also decrease. So A matrix will become half. So from the A
Ma'am,
matrix reduced it.
initially it was 8 matrix only, ma'am, into two symmetric matrix.
Yeah, so symmetric means what? There are 4. 0, 45 minus
4.
45,
Yes,
90. 4. Symmetric will be double of it. That will be 8. 2 symmetric will be double of that also. 16.
16.
Yeah. So initially it was 16. Then it became 8 because this 2s become S. So half happened of the A matrix because the number of laminas became half. The A matrix values will become half. So you will relate the A matrix with the same load given. So A matrix is will be directly proportional to your load and inversely proportional to your strain. So if A matrix is getting half, A inverse will be double. So the strain will also double and stress will also double. So modulus will remain same. That's what happened in this question, right?
So we have given Young's modulus 40, then it will become reduced to 20. I'm right, ma'am?
Yeah. No, Young's modulus will not reduce to 20.
No, longitudinal modulus. Longitudinal Young's modulus. And here also 16 matrix, ma'am. It's in two symmetric matrix and it is converted to one symmetric matrix.
This question I won't, I don't know. I think the modulus will remain same, but it's better you put it in the discussion. I am having confusion in this question. Okay, because Young's modulus will be stress
Yes,
by
ma'am, no
strain.
problem.
Huh?
Yes, ma'am, no problem.
Okay, because it Young's modulus, if they are talking about stress, stress is like in this question that I discussed here. So if the sequence is becoming double, the stress is also the stress is reduced by 2 times. But again, it will affect the strain also. And modulus is equal to stress by strain. So I think that relation will remain same, but it's okay. I think it will be better you ask it in the discussion. Okay.
Okay, ma'am. Okay.
Okay, then we'll end the session here. Thank you.